Hello everyone. In this video, we'll be looking at how to move your turtlebot around, that is, how to do path planning in ROS. For this, we'll be using the move base node. That is, basically the move base node is responsible to plan the path for any robot to move around in ROS. So to do so, we basically have two planners, that is the base local planner and the base global planner. These two, and you have different types of them, that is the type can be navfn, or it can be global planner, or it can be for local planner, it can be the DW local planner or the base local planner, that is the trajectory planner ROS, and there's caret planners. So different things which you can specify over the values over here. These are the particular type of config files which you'll be needing, that is the parameter files. Those are present for me in turtlebot_tutorials package under params, under this all files. So let me show you here. So this is the turtlebot tutorials package I've shown you to build in earlier videos. And inside that I have a param folder, and I have all this type of .yaml file, which are basically my files which specify some of the details inside it. So if you open the cosmap_common params, you have like the map type, then you have the obstacle layer, is it enabled or not, things like that which you would want to change if you're using different robots. And then comes, so you specify all of this and you can play around all the details. The next part is about giving the frame IDs according to user input data. For turtlebot, you can go ahead and use exactly these values, that is the global cosmap_global params _global frames, have argument global_frame ID. That is, this global frame ID is taken from the argument name over here, that is map. I'm pretty sure for most of the robots this will be same, but let's say for base frame ID, you don't have the base footprint. Instead, you have named it as robot footprint because you have made your own custom robot using the URDF package and everything. So here, when base frame ID will change, so you just need to specify the changes over here, and you can just copy paste this and you'll be good to go. And the last thing is about this raw velocities. You only need this for turtlebot because they don't let you publish directly to CMD well. So you need these two launch files which are coming from the turtlebot_navigation package. And then again, there are few remapping from ODOM and scan to different various topics, because in other videos or in other projects, you don't have scan topic and you have something like, robot 1 /scan, because you have like 3 robots. How will you name it? So you have changed the name. So that time you'll be using this. So this was all about understanding the amcl with movebase.launch. That is, in earlier videos, we have written the amcl node, and now we are writing the move base node. And this is how you are set to launch this. To see how this runs, let's look at it. So I'll open the terminal and I'll go and launch the world first. That is the ROS launch turtlebot_gazebo turtlebot world. Okay. The next thing will be inside my Catkin workspace. I have my amcl with movebase. So I'll launch ROS launch turtlebot_tutorials, and I have the name is amcl with movebase, correct? This is the launch file which we completely understood. So yeah, now you have it. It might give you few errors just while loading, that is the warning till it gets everything accustomed, and then once it does, then ODOM received. When you get this, you're done. Your amcl with movebase has been launched perfectly. The last part is launching the rviz. So for this, we'll launch the view underscore navigation, that is ROS launch turtlebot underscore rviz launchers, and inside that you have view underscore navigation dot launch file, and I'll launch this file. This is pre-built, so you don't have to add or remove anything. If you want to make use of this to have all the settings for the DW local planner, global planner, everything already there, I would suggest you use this. Otherwise you can have your custom rviz built. So now this is the 2D navigation goal which you'll be using, and yes, so let's click on it and select here. Okay, so if you see this arrow, this is the start of the arrow is the position where turtlebot will reach, and the way it's facing is the same way the turtlebot will face. Let's give it up, click it up. So yeah, the turtlebot, you see here the green line. The green line is the one it's planned. It has planned to go around, and now it has reached. Amazing, right? So you just have to use this and you can make the turtlebot go around in any direction. This inflation which you see is the obstacle inflation, which is basically the extra area which the turtlebot will avoid. We need this because we don't want the robot to collide with certain corners which we think the turtlebot might not hit to. Now this was the basic use of the global planner. What if you have some obstacle which you don't have it in your mapped environment? That is the time your local planner will come into play. So I'll add some wall over here and make it go around it. Let's see how it works. Okay, so I'll open gazebo, and so this is the way. I'll add a wall, a small wall over here, and we'll see how it goes. So okay, should this be it, or okay, let's give this the wall and get quite closer. Let's see if in rviz it has started. So in rviz it has already started detecting this wall, right? If you see, this is the area of what it sees. I'll give a goal over here, my 2D navigation goal. Initially it should have just gone straight and it would have reached to the position. Now it planned, but it saw that the wall is quite big, so it planned a way around it, if you can see it. And it saw that it cannot go from here as well because the wall is still over here, and so it's still planning. So if in gazebo you see that it couldn't have gone from here as well, right? So now it's going, it went from here to this position. So this was how the local cost map or the local planner comes into play. This is the wall which is being reflected in rviz is through the local cost map, and the plan is through the local and global cost map because the local plan did change. So this was all for this video. If you want to know more about the parameters which were be talking about in the earlier part of this video, please let us know in the description box below, and we'll have a separate video with all the details in it. Thank you. Keep watching Robometrics.